They are from the Department of BS Biotechnology and my roll number is 009. Today the topic of my presentation is transition elements. So first of all, we should know what are transition elements. Transition elements are those elements which are partially filled D or F subshell in any of their atomic state or commonly occurring oxidation states. What is their location? In periodic table, they are D and F block elements, and they are called transition elements because they have properties in transition between the metallic properties or metallic elements of S block and non-metallic elements of the P block. Now, the D block element is further subdivided into two categories, that is typical transition elements and non-typical transition elements. The typical transition elements are those which are paramagnetic and which show colored compounds, and the non-typical transition elements are those which are diamagnetic and which do not show colored compounds. Now, the F block elements are also called inner transition elements, and they comprise of series 4F and 5F series, and they are 4F and 5F series are lanthanides and actinides. Now, the D block elements are called outer transition elements, and they comprise of series 3D, 4D, and 5D. Now, discussing the general properties of transition elements. What are the general properties of transition elements? They show variable oxidation state, they form alloys, they are hard and strong metals with high melting and boiling point, they are useful metals, and used in industry like titanium, chromium, iron, etc., and they form colored compounds. Now discussing the general characteristics of transition elements. The first is binding energy. Binding energy is directly proportional to number of unpaired electrons. So on moving left to right in any transition series, number of unpaired electrons increases up to group 6b and then decreases progressively up to group 2b. Which means on moving left to right in any transition series, binding energy increases up to group 6b and then decreases progressively up to group 2b. The second property is melting and boiling point. Transition elements have high melting and boiling point, which means melting point increases up to the middle of the series and then decreases progressively. The third property is interstitial compounds. When small nonmetals like hydrogen, boron, carbon, and nitrogen enter the interstices of these transition elements, they impart useful properties to them, and thus they form interstitial compounds or interstitial alloys. The next and the fourth property is substitutional alloys. Due to similarity in size, they are able to replace one another, so they form a variety of compounds, for example brass, bronze, coinage metals, etc. The fifth property is paramagnetic behavior. So what are paramagnetic substances? Those substances which are weakly attracted by strong magnetic field are called paramagnetic substances, and paramagnetism is the phenomena which depends upon number of unpaired electron, means it is directly proportional to number of unpaired electron. As the number of unpaired electron increases, paramagnetic behavior increases, and vice versa. So it follows the same trend as binding energy, which means on moving left to right, binding energy number of unpaired electron increases up to group 6b. So paramagnetic behavior increases up to 6b and then decreases progressively up to group 2b. The sixth property is diamagnetic behavior. The relation of diamagnetic behavior with the unpaired electron is inverse. Diamagnetic substances are those substances which are weakly repelled by strong magnetic field. As the number of unpaired electron increases, diamagnetic behavior decreases, and vice versa. The seventh and the last property is covalent radii. Covalent radii first decreases, then become constant, and then decreases. The reason for this phenomena is 3D orbitals have contracted into electron core and so shield the outer porous electron more effectively from the nucleus. So this is a brief overview of transition elements, and that's all from my side. Thank you.